Focus. Hello and welcome to another Solana tutorial. Today we're gonna talk about Anchor program development. That's module 5, lesson 4, CPIs in Anchor. Also errors. So let's jump right in. Some people wanted me to be smaller, but I kind of like this. I kind of like having my hands all over, so I'm just going to continue like this. Objectives. Let's look at this from another side. Today we're going to do cross-program invocations, CPIs, from an Anchor program. We use the CPI feature to generate helper functions that allow us to easily do that. And we will also use the invoke and invoke signed, the standard Solana way how to do CPIs if we don't have any helper functions from Anchor. And then in the end, we're going to talk a little bit about errors in Anchor. Okay, now the TLDR. Anchor provides a simplified way to create CPIs using the CPI context. Yes, that's quite handy because it works a similar way as you define your instructions in Anchor and then you just essentially call a function from another program. That's what it feels like to me. You basically just call the instruction on the other program, give it the context, and boom, you did your CPI. We're gonna have a look at how that actually works. Don't worry, we scroll down. This video is not gonna end after 2 minutes, don't you worry. My videos don't end after 2 minutes, contrary to my sexual encounters. Anchor CPI feature generates CPI helper functions for invoking instructions on existing Anchor programs. Yeah. We also gonna have a look at that, which basically then, lets us call the other instruction directly like a function. Yes, as I said, lots of hand movement because I don't know what to say, so my hand tries to speak. Not even Italian. If you do not have access to CPI helper functions, you can still use the invoke and invoke signed like a regular Solana program would do, and then, put in all the accounts and stuff there. And for some reason, a small subtopic, errors. The error code attribute macro is used to create Anchor errors because Anchor errors by themselves are not big enough of a topic to deserve their own video, so we just push it in here. Okay, so in the first lesson about CPIs, here we learned that we can invoke or invoke signed with giving the instruction and the accounts, and then optionally if we invoke signed, the signer seeds for the PDA, and that's how we call another program from our program that's a regular CPI, and that is, somewhat challenging to build all of that. You need to manually build the instruction and then put in all the account infos, and that is a little difficult, especially if you're just starting out developing on Solana. Anchor makes that easier though. Especially if we just invoke another Anchor program, because then we can use this CPI context and do an Anchor CPI. Cool, so let's look into that. Cross-program invocations. CPIs with Anchor. So because I haven't said that enough, a CPI is when our program calls another program. Or a CPI is when a program calls another program. Hashtag composability. And we can still use invoke and invoke signed, but Anchor has this CPI context to do CPIs with. So the Anchor way to do CPIs is with this CPI context. So essentially what you gotta do is create an instance of this CPI context. And the cool thing is this CPI context is very similar to the normal context that we know from a normal instruction. Let me show you in the program that we had. Remember this? This was our first Anchor program. And here we get the context, and that context has accounts, bumps, program ID, remaining accounts. So essentially accounts, it knows which program ID. And that thing is similar to a CPI context that we will build. So the CPI context has accounts, remaining accounts, program, and signer seeds. So it doesn't have the bumps, but it will have the signer seeds that we use for signing. And that also kind of contains the bumps indirectly. So that's what that would look like in the type. Accounts are, so for this T, 2 account matters and 2 account infos must exist. The list of accounts required for the instruction being invoked. So we need both the account matters and the account infos for these accounts, for those accounts, if we would say it grammatically correct. Remaining accounts hey, if I would have read that tutorial, say, half a month ago, I could have done a much better job in the actual CPI of the CNFT example. Maybe I still want to do an update on that. Remember how we made it very difficult for ourselves because we didn't manage to get the remaining accounts into the CPI context? Yes, it just contains the remaining accounts. I want to have a look at this now. Because here I did a normal invoke signed because I didn't manage to put the remaining accounts in my attempt 1, this transfer. So the CPI context, new with signer, and here it has remaining accounts. Maybe I could have done something like CPI context is this, then CPI context remaining accounts is context remaining accounts. Then I wouldn't need all of that stuff. It would have been that easy. Okay. Oh no, it's not that easy. Hold on. You want a vector and you found a reference. Okay, it's still not trivial, but I guess now, like this, it will work. Point of this entire excursion here is knowing more about Anchor really helps you build better programs. So I wish I would have done this tutorial before I did the other thing. But hey, it's always a combination. You constantly keep learning. And then next time I encounter an issue like that, I will know how to solve it by just providing the remaining accounts here like this in the context after I've created it with a new with signer. But we're jumping ahead here quite a bit. I just wanted to prove to myself that I could also make it work with this CPI context now. Cool stuff. Save this, close this, never to come back. Point is, this CPI context has the accounts, the remaining accounts, which actually, in most cases, you shouldn't use it, he said 2 seconds after using it. But when I was using it, I was not actually handling accounts here. I was providing a Merkle proof, which is a different thing. And I totally knew what I was doing there. So in that case, it made sense to use the remaining accounts. In 95% of the cases, you don't need to and don't want to use the remaining accounts because it's not as safe as the typed accounts like this. For most things, those normal accounts are sufficient. That's also why the new just lets you provide the accounts and not the remaining accounts. Yeah, then obviously the program, we need to know which program we're calling and the signer seeds if we want to add signatures for a PDA or for PDAs. If our program signs for something, then we need to provide the seeds. Cool. How do we create such a CPI context? Well, with CPI new or new with signer if we want to add signers. And that's pretty simple. We just say which program and which accounts. Then we have the context, which again just corresponds to what we have here. Additionally to the context, we then also need the instruction with the parameters and their accounts. So the context is just one part. As we will see later when we actually call it, the context is just the part inside the instruction. And then we can have more parameters here as well. So it is very similar to this and this context plus parameters, context plus, in this case, we don't have parameters. Again, jumping ahead too much. So new, if we just create a new CPI context, as I said, program and accounts is sufficient. And what that does is it just stores the accounts and the program and keeps the seeds empty. And also the remaining accounts are empty. Actually, this is a new vector. So actually the cleaner way might be to just append. And then similarly, if we have the new with signer, then we can also provide the seeds and the signer seeds will just be taken that we provide. And again, remaining accounts is still just a new vector. I should have really read that documentation a month ago. Damn it. Would have made my reference implementation much cleaner. But hey, I can still make a pull request and I'm gonna. Don't you worry. Look at that. It compiles. I mean, I still need to test it before I publish it, but that's a task for another time. CPI accounts. One of the main things that the CPI context simplifies is that the accounts are now a generic type. and you can pass in any object that adopts the toAccount matters and toAccount infos traits. Cool, so I got that right by reading this. It needs to have both of those traits. And conveniently, if we hashtag derive accounts, if we add that macro, then they already have that. Convenient. So our accounts, those ones, right? The ones that we did here, like the close accounts and the sum accounts, where we said derive accounts, then they will have those toAccount matters and toAccount infos. It's pretty handy because then we can put the sum accounts right into the CPI context or the close accounts. So if we now want to invoke an instruction of another Anchor program, when the program is published and it has a crate, then Anchor can generate instruction builders and CPI helpers for you. And we just need to declare it like this with this CPI feature. Now, I would be interested if I have to have it published, because there must be a way how I can just use my local Anchor program and another program references that. And I want to find out how that works. So let's create ourselves yet another Anchor program. GM Anchor. While this is slowly building, simply declare your program's dependency on the program you're calling in your program's cargo toml file as follows. So easy. Path to the callee. So that's the program that we call. I'm the caller, he's the callee. By adding this CPI feature, your program gains access to the callee CPI module, such that we can then do stuff like callee CPI and their instruction. For instance, in the Anchor SPL, in the token, we would have those functions, and the CPI feature enables us to access them. The CPI module exposes callee's instructions as a Rust function that takes the arguments, a CPI context, and the additional instruction data. So this is the exact same as we get it into our program context and then all the instruction data. This is the exact same when we now call the CPI. When we call that other program, we also call their function, provide the CPI context and the input parameters. Like so, program, CPI, then the function, then the context, then the parameters. But we don't have any parameters here, so that's quite boring. These functions use the same format as the instruction functions in your Anchor programs, only with the CPI context instead of the context. Yeah, it's as if we just call that other function. Hold on a second. We could even recursively call our own program. Why don't we do that? Why do I try to build myself a new program if I can just call myself? Because I want to know how to include the new program. Yeah, that's why. I remember. Maybe I let the GM program call itself recursively. Oh, by the way, do you see my nice transparent Solana logo? I love green stuff on shirts. That makes perfect sense with a green screen. Okay, perfect. It built. So let's make a GM instruction. And I'm going to give you one, which is a number, a U8. How many times we say GM. And then we just say GM. And if we still have GMs to say, then we just recursively call the GM instruction again with the same context and one GM viewer. So that's just a recursive call to GM. Point of this is I don't need to go through the CPI context if I call an instruction or a function inside my own program. I could, and I don't need to. What's your problem? Result must be used. True story. Oh, right, we're in Rust. You don't like those. So either we call another instruction or we end. Okay, then we need our validator. Perfect, that compiles. Validator running. Yes, deploy. Okay, GM program is deployed. Now let's see how we can call this GM program from our other program. Let's make ourselves a new instruction. How about no accounts? No accounts, no parameters, just call it. What we do here now is a CPI. So the way we do this is we need the callee CPI and then do something. And to get the callee, we gotta add the dependency. Do you think I can just add the local path like GM program, but that's not the crate. GM Anchor. And that's the path to my program. And I use the CPI feature. If I save that, look here, there's an error. So okay, it doesn't like this. Well, then proper absolute path instead of this. Okay, can you build? Oh, wait, but now it is trying to build the Anchor program that I have here as well. It is also trying to build this program. But this program builds. Then I get... Okay, let's try and fix that. This error originates in the attribute macro program. Well, I don't know, maybe just supply this one lifetime. Then you complain that unused parameter. Okay, what if I just use some account? Not because I want to use it, but just so it stops giving me errors. But hey, it could compile the GM Anchor. Great. Okay, sure. It just doesn't like not having accounts, I guess. And if I steal your accounts, you're gonna be fine with. Oh, that's what you mean. That's what I'm missing. Haha. Okay. Sorry, yes. Yeah, sometimes it takes me a while to figure these things out. Oh man, didn't get that for the longest time. Okay, but now, yeah, way better. Cool. We were able to build both the GM and our program. Great. Finally, time to get to the interesting part with CPIs. Because now that we have included our GM Anchor program with the CPI feature, we can here include or use our GM Anchor program, and then we can in our instruction say GM Anchor CPI. Unfortunately, it doesn't provide me with ideas here. So CPI and then our function. I'm just gonna copy the name of our instruction, a GM instruction. And then it's as if we call this function here. So we need to provide it the context, which is not going to be a normal context, but a CPI context. And then this GM's U8. We're going to provide the CPI context with a new context. And that would just say which program and which accounts. And then once we have that, we provide the GMs. And I'm just gonna start with one GM. And that should then also give us a result because, you know, what comes back from such a function is a result. It's also the same with the CPI. It will give me a result and then I can just, you know, return it. You know, I could be like, return this, or the short way is just not writing a semicolon and then it returns this, whatever comes back from here. If the GM CPI raises an error, then also I will raise the error. And if it proceeds with okay, then also I say okay. That is that. So we just need to know which program. To make things easier, I'm gonna move this out such that I have better typing in here. You need an account info and the accounts. So the program we call, obviously we need to declare it in our accounts so that no accounts doesn't really work anymore, because we at least need one account, not the system program, but the GM program, which now the question is, how do we get that in there? I did it once. So for the CPI to work, let's create a struct GM program and then we implement Anchor ID for it, and we get the actual ID from the declare ID of the other program though. So from the GM Anchor, we get the ID which, we defined in here in the GM Anchor. And then here we should be able to access the ID and implement this for the GM program. That's just a little bit of code that we need to add such that we can then use the GM program down here to type our Anchor program for that Anchor account with this GM program. Cool. So no accounts is not correct anymore. Let's also call that GM accounts. Why not? Not confusing at all, because those GM accounts are other GM accounts that the GM accounts in the GM program. So the first thing, the program we get from context, accounts, and then we have the GM program, because obviously we need to pass in the GM program such that we can then do the CPI on it. Solana requires all the accounts up front, and then the remaining accounts. So what other accounts does this CPI context need? Well, those are now all the accounts that this thing requires, so the actual program. But to make it simple for myself, our own GM program, although the naming here is not so great, so let's just call it GM program. Here, the GM program we then provide also with the program that we have from our context, accounts GM program. And I think the type needs to be to account infos. This one needs to be an account info, and also the program itself also needs to be an account info. So I have the program, the accounts that we type as the GM accounts from that GM program. You now don't like the types. So Anchor is already making sure that we have the right types here. So it must be from the same type. And that is looking better now, I guess. Still doesn't like the CPI context here. Oi, 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 oi. So one is from GM Anchor CPI accounts and the other one is from GM accounts. So, right, I know what this is. So since we do the CPI here, we can't use the normal accounts, but the accounts are now also in CPI. So the GM accounts Tata CPI also has or should have such a GM account. It's a private struct? No. CPI accounts GM account. Okay. So CPI accounts GM accounts. This is not complicated at all. What do you mean? Okay, getting there. Now the GM program expected an account info and you found the program. Well, okay, and now we just do this to account info. So it's actually not strictly typed anymore because those are now just account infos. But then the program will check the typing again if that's actually the correct program. So build one more time. We'll get there. Don't worry. The more errors I fix, the more happy I am if it compiles. Yeah, come on. Yes. Love it. Okay, nice. Look at that. It took us an hour, but we got the CPI context to compile. It built. Let's deploy this. Oh, and then obviously I also need to deploy my other program. Okay, deploy success. We are going to call the mygm instruction, which doesn't take any arguments, but does need the account for the GM program, which is just a new Web3 public key. And there I just copied this one from here and we put it as the public key here as the only account. And then we just call RPC and that's it. No such file or directory. What happened to my node? I mean, this has worked before. Yeah, okay, sure. I have huge dependency problems but another 30 minutes later, we managed to install our node again and run this test. Cool. So the GM test has worked. Looks good. The log messages say that our program was invoked and then the GM program was invoked. Nice. And it said GM. But if I don't call one but 3 GMs, the GM program says GM 3 times. Cool. So that is how we do a CPI if the other program is an Anchor program, because we can directly there call the instruction is if we were to call that function from the other program, just that we go through this CPI and provide the right context with the right accounts. And Anchor makes that pretty simple for us. However, what if it's a non-Anchor program, or we just don't have the crate? It might not be that easy. We might not have the source code. Then there are again two possibilities. Number one, whoever wrote that program was so nice to publish a crate with helper functions that allow us to easily build the accounts and instructions. For example, the Anchor SPL crate has helper functions how we can call the SPL programs through Anchor, and they are virtually identical to what we would get with the CPI module from an Anchor program. So for instance, the mint2 helper function and the mint2 accounts struct, those things in the Anchor SPL. The mint2 again takes a context and the amount, so as if it was an Anchor function, even though it's not. But it provides us this helper function to make it look like it was an Anchor program. And the mint2 struct, that is essentially just telling us which accounts we need, the mint2 and authority. So it could look something like this. We create a CPI with a new signer, so apparently the authority is the program, our program in this case, with those seeds. So essentially just mint and then the bump. And from the Anchor SPL token mint2, this is a struct that has the accounts that are required, namely the token mint, the token account that is minted to, and the authority. And when we provide those accounts and the token program ID and the seeds in the context, we can plug that into the Anchor SPL token mint2 instruction, where it also requires the account, and then that will perform the CPI. The second thing that can happen, if you want to call instructions where there are no helper functions that provide this nice context, then you can still go the regular route of using invoked signed or just invoke, where you basically have to build all of that yourself manually. You can follow a similar pattern if you decide to use an accounts struct and CPI context to organize and prepare your CPI. So essentially you could build that yourself. You write yourself a mint2, which takes the CPI context and the parameter, but then you manually map that to a result which just hides an invoke signed that contains the instruction, the accounts, and the signer seeds, as we've learned in the module about CPIs up there. And then you can just call this one, or you just, manually build yourself this. You don't even need to go through the CPI context if you don't want to. You can just put that inside your code. And here again, this makes it quite easy because it builds the instruction for you. You might also need to do that manually and provide the account matters and the instruction data and all of that manually. Could happen. So, instead of going the simple route here in calling our GM program, we could do that manually. And yeah, just to prove that I still know how to do this, and I'm a pro and I can do that quickly, I'm gonna quickly do it that way. So let's pretend we don't have this CPI stuff and those accounts. We could still just manually call it with Solana program invoke. But for that to work, we need to, of course, add the dependency, Solana program. And now we can say program invoke, and we just need the instruction and the account infos. So the instruction will be a Solana program instruction, and that again needs the accounts, the data, and the program ID. Starting with program ID, you are a pub key. This I can get out of my context. The GM program has a key, so that's the program ID. Then the accounts, well, that's a vector of account meta. And we just have the one account, but we need an account meta, so we need to define it like this. Is it read-only and is it a signer? In our case, it is read-only and not a signer. Okay, that should be sufficient for accounts. Then the data is a vector of U8s. A vector, and my U8 is 6. Why not? That should hopefully be sufficient for the instruction. Then It still has mismatching types. So as James also writes it here, we still need to map error into such that we get the program result and not just a result. Actually, no, that we get a result, an anchor result, and not the program result that we would get from a normal invoke. So we need that because we are in Anchor. Still not? It's called new read only. Sorry. Apparently, I was copying code from a different version. Whatever. It's a new read only. Expect a pub key. That's okay. We just say dot key. Yeah. Okay, then account infos. It's just a slice of all the accounts and we clone them. And then we just provide the one account to account info. And that is how we would call that manually. Let's see if that would build. Perfect. Let's test it, see if it works. Oh, one failed. Oh yeah, of course. Once again, we're missing the instruction discriminator because the data is now not just the actual instruction data, but also since it's an Anchor program, it takes the first 8 bytes as the instruction discriminator. So we need to provide that correctly as well. So that is the hash. We take the first 8 bytes, 81, then 5D, 93. Just because I'm too lazy to let the program convert. I could also let the program do that, but 03, I can do that in my head. 3. 0E, I should also be able to do that in my head. 15. No, fuck. 14. Yes, 14. Sorry. Yes, a bit complicated doing that manually. But now we have the 1, 2, 3, 4, 5, 6, 7, 8. What? 8 bytes for the destruction. For the instruction discriminator, destruction incriminator. And now that should actually work. Cool. And now the test is passing. Yeah, nice. Solana confirm now says 6 GMs. Nice. So that's the manual way to do it. I mean, if you know what you're doing, it's not that much more difficult than the Anchor way. But especially if you're already calling an Anchor program, especially with the getting the discriminator manually, it is a bit more of a hassle. I would recommend this only if you have no other way of calling that other program. The simple way, functions that are provided with regular Anchor programs. I could also call it once with this one and then with this one. So first I call 3 GMs with this and then I call another 3 GMs with this one. Let's demonstrate how they both work next to each other. I just do 2 CPIs. And here you see first CPI 3 GMs and then another invoke 3 GMs and that's it. We learned how to do CPIs in Anchor. This first way of doing things is then a mix of both of them. It's the Anchor way to do things, but you require a function to map the accounts correctly. And you require a function that builds the right instruction. And if you don't have that, you can do it manually. I want to make a separate video about working with tokens in Anchor, not just the SPL library, but also Metaplex stuff. This is gonna be the next Anchor video that I'll be doing. We'll go more into depth there, so I will skip this for now. But I think you got the idea of what that does, right? So just call this function from the Anchor SPL, provide the context, and again, the accounts. You have again a function, which is, pretty much the same as we did here, just that we didn't have to fake that function and this one because we had an actual Anchor program. So those are essentially just wrappers that make it easier for us to do it from an Anchor perspective. Anyway, last topic for today, errors. We're deep enough into Anchor at this point. Deep enough that it's important to know how to create custom errors. Custom errors are very useful because it makes the debugging easier. You can have a cleaner program because you provide verbose errors that actually say what's going wrong and not just custom error. Custom error 0x0. We want to have verbose errors, and Anchor supports us in that way where we can just name errors conveniently and return them in a convenient way. So all programs use the same type, this program error. That's what we want to return from our entry point. However, when we're writing an Anchor program, there is an Anchor error, which is an abstraction of the program error. And this Anchor error has the additional information of an error name and number. More importantly, the name. We also have the error code number, but the name is helpful for people. We'll also get the location in the code where the error was thrown and the account that violated the constraint. So that's the origin. Where does it come from? And if it was an assertion, which values were compared. There are two types of Anchor errors. The Anchor internal errors that the framework returns. So something like account verification failed, invalid signer seeds, something like that. Or custom errors, those are the ones that we create. We as developers using Anchor, we create custom errors. And we can add errors for our program with the error code attribute. Pretty simple stuff. We just use this attribute macro and bam. Similar to what we did with accounts, we now do with errors. We put that on top of an enum where we just put our error names, and we can then directly put a message here on top and say this error should get this error message, and this error message is then neatly displayed when the error actually happens. Clients can then display this error message if the error occurs. Great. So this is how we define that error. Let's go there right away. Maybe let's do it in our GM program because it's less crowded, and be like, we only support a certain number of GMs because we don't want infinite recursion. The actual limit is already 255, but let's say we only support 10 GMs. More than 10 is too much. So we define ourselves an error, pub enum GM errors, and we add this error code attribute here. And then we can define the error. So we say this is a too many GM, and I will add a message. Not sure if I would put that thing here as well. Whatever. This is my error message. And then how do we actually put that somewhere? We can use the error or error macro. Don't ask me what's the difference. These add file and line information to the error that is then logged by Anchor to help you with debugging. So error with this error. Okay, so that's if we return it. This already returns a given error. This just creates me the error, and then I still need to return it myself. And if I use the just ERR, then I can directly just write this. So if GMs are larger than 10, then I want to return the error. So either I do the long way and create myself an error with error macro, and then my too many GMs error, GM errors, too many GMs. This will now create me the error. So we have an anchor long error, but we still need to return it inside this error that makes it a result. And then that is something we can return. The shorter way to write this, so if we weren't doing this, we could also just say error macro and put that here. That does the same thing and is a bit shorter. Expected unit type. What am I doing wrong here? Yeah, I could put an else here. Okay, that seems to fix it. Still want to find out how I can just do it with a, kind of a guard. Because I don't want to have all of that in an else block. Let's just read more code that James writes. Oh, you still do return that error. Okay, so maybe there is a difference between not writing it, because then it returns it up to the if. But if I would do return this, so there might be a slight difference. This does not work, not writing the semicolon, because that just gives it out to the if, but a return with a semicolon, that does work. Okay, learn something again. Great, because that return gives it out of the function directly, and without anything, it would just put it into the if, and then expects an else to also have the same type. And since I didn't provide an else, it was confused and it said that doesn't work. But cool, we're getting better in Rust as well. That's amazing, I love it. Okay, so we can do that. We can just return too many GMs if it's more than 10. So let's quickly see what that would look like. If here I were to say I want 11 GMs and I rebuild and redeploy both of my programs, then one test has failed and we already get the error, anchor error thrown here, line 12, error code is too many GMs. And even the message, too many GMs requested, maximum 10 GMs. So that's pretty, obvious what has gone wrong. We just requested too many GMs. Maximum we can do is 10. Alternatively, you can use require macro to simplify returning errors. Oh yeah, we could also do that. Instead of that, we can also just require that our GMs are smaller or equal to 10. Otherwise, we put the too many GMs, and this code is now redundant. And this is like an assertion that you might know from other languages. We assert this. And if that is not the case, then we return the error. So you need to logically flip your if for returning the error. Because if that is not the case, then our error is returned. So that's why the greater has become a less than or equal. And if we do that, then we even get more information. If we request 12 now, for instance, because then it also has the values from the comparison, right? That's how you say it, right? The values from the comparison, from comparing those values. It sounds so weird when I say it many times. Comparison. All right, we deployed the GM program again and we tested and it's gonna fail. And we once again get the error code too many GMs. So 6K is where our custom errors start apparently. The ones below, like 3K or something, are the Anchor internal one. And we get too many GMs requested. And I would have expected that it now tells me that it compared it to a value. Oh no, wait, it doesn't. Because we don't compare it, we just evaluate this to a Boolean. Okay. But there are more requires, I'm pretty sure. Yeah. For instance, a require equal or a require negative, require key equal, greater than equal, and then there's also a less than or equal, pretty sure. I would expect something like require less than or equal. No, we don't have that. Okay, then we just need to use this and invert it. So what we can also do now, of course, is we require not just one Boolean, but we require that the GMs are greater than or equal to 10. Let me just double check that I get this right. So it requires that value 1 is greater than or equal to value 2, because if it's not the case, that's again the inversion, then the error is thrown. So here we see what is happening inside the macro. If it's not the case, then we return the error with values, and this will then give us the values for the comparison. So let's do that. So that GMs must be greater than or equal to 10. Otherwise, we shall get a GM errors too many GMs. One more time now. There we go. It failed as expected. And conveniently, error as before, but it tells us now the left has this value and the right has this value. 9 and 10? Did I get my logic the wrong way around again? We started 11. 11 is greater than or equal to 10, so that's true. So we continue. Oh, I got my logic the wrong way around. Damn it. Sorry, my bad. Of course, I need to do it that way. And because there is no less than or equal to, I need to just put the 10 first and the GMs on the other side. Yep, sorry. That can happen. That's why you test. That's why you look at that. And now it's going to tell me that it compared 12 to 10. There we go. That's what I expected. We got the too many GMs and we compared 10 to the left and 12 to the right. And 10 is not greater than or equal to 12. That's why it fails. Okay, 10 is not greater than or equal to GMs. There we go. That's it. So there are different requires. You can also compare keys with require, key equals. and a bunch more, as you can see here. Yeah, and that's errors in Anchor. I would say good enough. We've seen 3 ways how to do them. We can do all of them to make it redundant AF. Just to make really sure that there's not more than 10 GMs per call. Yeah. Okay, I want to end it here because I don't want to go through the demo, because we did do our own demo, and you can totally do that. Go through it with James. I do promise you that we will make another tutorial where we work more with tokens in Anchor, where we will call those functions. Yeah, I don't want to do that writing exercise. You can if you want, or do the challenge with the student intro program. And as always, James provides the solution code. If you get stuck, you can look that up. Yes, the bells are ringing here in Austria. It's time for me to go. I hope that you learned something today about Anchor or Rust or life in general. Maybe you just learned that you're on the wrong path and you don't want to do Solana development at all, then that's fine too. But I hope that you do want to stick around for the journey of learning Solana development more and more. Everything that there is to learn. Well, that doesn't work ever, but we can at least get our hands dirty and really learn a lot here. Okay. Cool. If you have any questions, leave them down below in the comments or in my Discord server or on Twitter, and let me know what you want to see next. You can also find the source code of what I wrote today down below. And of course, the links to James's course and other Anchor resources. Anchor is a cool developer tool. It's really much easier to develop in Anchor than it is in native Rust. However, I do recommend understanding both, and I hope that my videos can contribute to that. So, I will see you in the next tutorial. Make sure to like and subscribe, and check out those videos, and then I will see you in the next one. As always, bye-bye. Have a good day. And don't let the glass chewing ruin your teeth or your mouth or whatever. Goodbye!